is Carlos A. Santiago Ortiz, and I'm going to talk about the effect of seismic movements on the geodetic survey and topography of Puerto Rico. The seismic movements that I'm going to talk about are referred as earthquakes. For instance, as a survey and topography student, I am concerned about the changes on the constant moving Earth. These changes on the shape, form, or space of the Earth can complicate our work and can lead to the failure of any project that we evaluate. A seismic movement or an earthquake is the shaking of the surface of the Earth, resulting from the sudden release of energy in the lithosphere. Earthquakes can range in size from those that are weak, that cannot be felt, to those violent enough to toss people around and destroy whole cities. The seismic activity of an area refers to the frequency, type, and size of earthquake experienced over a period. Also, I would like to explain that the earthquake are caused by the sudden movement of the tectonic plates that basically are ginormous masses on the lithosphere of the Earth. Also, to explain what an earthquake does is that in the epicenter, a focus led a seismic wave that traveled around, like a mechanic wave or seismic wave that used the Earth as a medium to travel around the area of the seismic. The problem that I'm going to talk about is about the precision and the measures, because an earthquake can change the measurement of things on time in a brief certain time. And the problem basically is that if you are sure about one measurement and you have a project and, and because of a seismic movement or earthquake, those measurements changes that can lead to an error and can be fatal because it can lead to death or basically failure or chaos in a project. And that's why I'm going to talk about the measures. In recent researches, it has been discovered that major earthquakes or significant plate movement can change or distortion the peak of mountains and the subtly stretch or compression of a certain area. With that information, it's easy to think or perceive that if spaces of the Earth have been the same since the beginning of time, because earthquakes and sudden plate movements are something natural and it depends of time happens. That's why I said that the measurements of the areas or spaces that we have maybe are not the same from the ones millions years back. As an example to what I'm talking about is the earthquake in Nepal in 2015. According to data from the National Administration of Surveying, Cartography and Geoinformation of China, the devastating magnitude 7.8 magnitude earthquake that struck Nepal in April of 2015 displayed the summit of Mount Everest 3 centimeters to the southwest. In addition, scientists report that the densely populated Kathmandu Valley moved more than 1.5 meters to the south to the south and rose nearly a meter during the earthquake. According to the AFP, the same situation occurred in Japan when the earthquake of magnitude 9 of March of 2011 caused some part of the country to move up to 4 meters, according to the National Geographic. Those examples are important because those those three earthquakes led to big movement of places, like displacement of area and spaces, and that's why I've been used on this presentation. This chart is about the Kathmandu Valley, Nepal, and when the Mount Everest changed its summit by 4 meters. And here is the graphic about how it's been how the earthquake changed it. Earthquakes can also alter a force as strong as gravitation. Data collected by the gray satellites allowed to establish that the earthquake in Japan of 2011 was strong enough to reduce the gravitational field in the region of 2 millionths of Gauss, reducing the crust of the Earth according to life science. To compare, the gravitational force on the surface of the Earth, its average is 980 Gauss. Among other possibilities, consequences of earthquakes, some scientists talk about volcanic eruptions, series of earthquakes of lower strength, possibly even in other parts of the world, as well as destruction of glaciers and the acceleration of climate change. Here, in the left part of the presentation, we have a picture about South Africa, about Africa, and it shows a brief change on the gravitational field, where the parts of yellow and blue are changes because of earthquakes. Also, I want to explain that the 2 millionth of a Gauss, it's basically a very tiny digit, but considering that on Earth we only have 980 Gauss, it's very an important fraction, because those 2 millionth of a Gauss happens around 17 seconds that were the time of the earthquake. So that means that if in the beginning of the time that the world starts having constant movement and constant earthquake, could be a very important number that could change the Gauss or gravitational field on Earth. Also, seismic phenomena or earthquake can change and interfere the magnetic field of the Earth. In 2003, scientists found marked changes in the magnetic field in the Asia-Pacific region. In 2004, however, the changes focused on South Africa. The Earth's magnetic field has been inverted hundreds of times over the last billion years, and the entire process could take thousands of years. The decline of the magnetic field is also opening the upper atmosphere of the Earth to intensively charged particles, according to scientists. Also, to explain the graph and the picture that we have here, the picture are the magnetic field acceleration and the gravity field anomaly in Asia Pacific region on those years. And in the graphic, you could see how the red peaks change at the beginning and a stretch at the end. And that's very important because also as I said before, these are these are constant things that change. And if in the past those same changes will accumulate to become a greater number. Also, as major to interpret what is the important thing about the the movement, like the movement of the Earth important. We have a very important concept in modern geography that it's called a divergent plate boundary. I'm gonna explain it like this. Uh, we all know that like tectonic plate are bigger masses on the lithosphere of the Earth that moves and also provokes earthquakes. Well, when two plates, when two tectonic plates collide, they they provoke a separation between them, and that's called the divergent boundary. On the picture, it can be seen how the oceanic parts goes to different directions, and there starts a rift in the astrosphere. That led to magma and new materials from the astrosphere emerge to the surface, and that creates a rift valley. A rift valley is a space where new material like magma is constantly emerging. That means that it will never can be measured because it's new material that is emerging. That means that every time it will have more, and that means that that can lead to changes in the spaces of those areas. In Puerto Rico, this problem is important because we are in the middle of two plates. We are touched by the Caribbean plate, and also we are touched by the North American plate. Uh, this problem in general is important in Puerto Rico because we are susceptible. We have we are susceptible. An earthquake is commonly expected to happen on places like Puerto Rico and the Caribbean, and that's why everything that I talk on the presentation is important, and that's why we should be aware of the changes that can be that of the changes and the shapes that can be led on the projects that are managed on the geodetic survey and topography in Puerto Rico. Um, as a solution for the problem, I think that a biannual remeasure of the areas that are compromised by the movement of Earth can be very helpful and can prevent a disaster. Also, if a major earthquake happens during the project, it should be stopped and as a safety measure, uh, it should be stopped as a safety measure and resumed after assuring that it's safe and that no further project problem would affect the workers, nor the users or the project. As a conclusion to this project, I would like to explain the problem, the basis, and the solution, and why it does affect Puerto Rico. For first instance, the seismic movement or earthquakes can change and distort spaces and can change spaces, and if we, as a geodetic surveyor and topographer, take a measure, and that measure is changed by any seismic movement or earthquake, it will change the precision and the efficiency of our work. If we, as a topographer or geodetic survey uh, collect data that is not correct, and we go on and we uh, present that to an engineer, and the engineer make a project, it's going to be a bad handled project, and it could be led to a disaster like we have in the left picture. It can be very uh, it's very important, and it could be very helpful to remeasure the remeasure like basically remeasure the areas that people are be working on, because it could help lives, and it could be very useful. I want to thank you for your attention, and that's my presentation.